All right, here we go again. Lesson 2.06, area of special quadrilaterals. All right, so we're going to talk about just a couple of the special quadrilaterals we talked about in 2.04, the trapezoid, the parallelogram, and then we're going to cover some of those concepts about the rectangle again. So first, we are going to discuss a parallelogram. Remember some of the qualities of a parallelogram where the opposite sides are parallel and congruent. Well, yes. Man, I am not very good at drawing these. Let's try to straighten that up just a little bit. All right, so this would be parallel to this, and then this would be parallel to this. Okay? All right, so what we're going to do is we're going to talk about how you calculate the area of a parallelogram. It's actually very similar to a triangle, right? Because honestly, this is just two triangles put together. You can split it a couple of different ways, but like if we split it, that's just two triangles. And remember, a triangle is 1/2 base times height. So a parallelogram is literally just two triangles. So instead of dividing by 1/2 to get the triangle, we just have to multiply the base times the height. So the area of a parallelogram is base times height. So in this situation, they will give you the base, and they can give it to you. Remember, it has to be perpendicular to the base. The height does. The height has to be perpendicular to the base for it to be a true height. So let's say this one is 7 inches, and it has a base of 5 inches. The area of this parallelogram would just be the base times the height. So it would equal 35 square inches. So in my last unit, I did SQIN for square inches, but it can also be written with the little square, the subscript, the exponent too, okay? So that's how you do it. I do want to show you one more just because they have a couple of different ways to show you the height. It can be on the inside of the figure like that, or sometimes they actually drop the base out here, kind of like that obtuse angle I showed you on the triangle in that last lesson. So the height could be on the inside, like in the pink and blue, or it can be on the outside. Still calculate the area the same way. It doesn't matter one way or the other on that one. Okay? All right. The other type of figure you're going to see is that trapezoid. We're going to see a trapezoid. Trapezoid has two sides that are parallel, and then two sides. If it's an isosceles trapezoid, those two sides on the outside would be congruent. Mine's definitely not an isosceles. So we'll just leave it like that. But I am going to go ahead and draw that height on the inside. If it's upside down, they can just drop it down to the extent, it doesn't matter. Like if you wanted to draw it here and extend that base, it's gonna have that same height. This height is gonna be the same as that height. Okay, just wanted you guys to see that. Okay, that was kind of fun. All right, so we'll put this back, and then we'll give this a length. Let's say it's 6, and this can be 10. All right, so the area of a trapezoid is 1/2 the height times, actually I want to do it a little differently, and because I want to explain why we're doing what we're doing. So I'm going to do 1/2 the base 1 plus the base 2 times the height. And the reason I wanted to write it like that is because what we're doing is we're taking this length right here, this 6 and this 10, and we're averaging those two lengths to come up with one length that would be 8. And the reason I know it's 8 is because I used some mental math over here. 6 plus 10 times, we'll fill that piece in later, 1/2 times 16, which is 8. Okay, so the reason we're doing 1/2 the base 1 plus the base 2 is because we're averaging it out to get 8, and then we just have the rectangle concept. We're just averaging the bases to get the same length. And it's almost like taking this piece, flipping it over, and filling in this piece to make that rectangle, if you guys can visualize that. That's how this formula works. That's what you're doing. You're averaging the bases and then multiplying it by the height. So let's give this bad boy a height. The height for this one can be 4. Okay, so once you average those bases, you can just multiply it by 4, which would be 32 square inches. Okay, so again, if you need to, write this down, pause me, write this down, because you will have a trapezoid question that you will have to calculate on your test. All right, the last two questions, quiz, I should say, the last two questions for this one would have to do with your rectangle again, or a parallelogram. It's kind of going back to that concept where they give you the area of the parallelogram and they give you either the base or the height, and then you have to solve. So let's say the area is 50 square inches, the base is 5 square inches or 5 inches, and then you have to calculate the height, or you have to figure out the height. Remember, once you plug in your knowns, all you have to do is solve. Do that one step of solving. The height would be, in this case, 10 inches. Okay, all right, short and sweet on this one, but I hope it helps. If you guys need anything, don't forget I'm here for you.